Welcome to California Exotic Technologies. This is an update on the magnetic fusion device. I'm going to give a quick explanation of the basics of it. First, let's start with a simple explanation of the LED. Quite simply, we all know that a AA battery, whether it's a AAA or AA, which is basically 1.5 volt, will not light up an LED. So if I connect this here to the LED, like so, I connect this. As you can see, there is no light coming out of the LED here. That's because an LED requires approximately 2 to 3 volts to light up. So what's the best way to do that? Well, these solar garden lights basically contain a simple jewel thief inside. So what happens is when we connect a AA battery, as we already have here, connected up to the garden light circuit, let's go ahead and see what happens to the LED. Now you guys can see that, but the LED lights up nice and easy. Let's try it again. As you can see, the LED lights up very simple here and very easily, and that's done with the same battery. All we're using right here is a AA battery, and it's connected up, but it's going through the solar garden light jewel thief, or basically the voltage multiplier, the amplifier. So basically what we have here is a simple jewel thief from a garden light. We have that connected up here to a stepper motor. Now a stepper motor creates an AC voltage, so what I needed to do was I put in a bridge rectifier. This is the bridge rectifier I put in, and I put it in the circuit right here, and that turns the AC voltage from the stepper motor into DC. And when I turn the stepper motor, which I'm about to do right here, you'll see the LED light up because it's going to a DC voltage. It doesn't light up a lot because it's a very simple circuit. So far I haven't amplified it more, but I don't know if you guys can see that. But you can see it lighting up when I turn it. And then the multimeter here, the multimeter is also lighting up when I turn it, as you can see. Now without the bridge rectifier, with no bridge rectifier, I'm not able to light the LED because the LEDs only run on DC voltage. So basically, it's a very simple circuit, very powerful. It generates a lot of energy. And basically, if you're curious about how to connect the nose cone, it's very simple. I basically have one of these fans right here. They're called pinwheel fans, and this one happens to have like a love heart shape on it, which I think is really cool. So what I did was, I have a connector on here from a cassette reel, an old cassette tape reel, and I've put one of the screws through the top. The screw goes through the top like this, and then I quite simply connect this. I don't know if you guys can see that, but the screw comes through here. There's a screw coming through, and then I basically bolt it onto the top like this. So I'll go ahead and put the screwdriver in here and screw that in. This makes a very tight, secure screw. There we go. And now what we have here is quite simply a pinwheel fan hooked up to a stepper motor. And then we can use that to generate energy. Very simple, very effective. Generates some decent energy. And then you can see here also I left the solar panel from the garden light on there, so I'm also getting solar energy also charging up to help charge the circuit. So the circuit is very simple, very powerful. We still need to increase the amperage a little bit more. We hope to start charging these D-cell batteries here, so we can start using it to drive a motor on the bike. So that will really help once we can get that going. So that's basically the simple circuit and basically how it's built. Very simple. One interesting discovery we also made today was supercaps charge very well with a stepper motor. And so that's one way to store the energy instead of a battery. And we can also use a dual system, which we'll explore later. Anyway, thank you for watching, and have a great, wonderful day, and good luck with your scientific work.